Okay, so when we're talking about coterminal angles here, okay, have you ever heard the word? Have we heard the word terminal before when we're talking about when we're drawing angles? Which one are we talking about? Yeah, okay, the one on the left. What do you mean by the one on the left? Okay, so yeah, so when we're drawing an angle in standard position, there's the first one. What do we call the first one? The initial, and then there's the other one. What do we call the other one? Terminal. Okay, so coterminal angles. What do you think co means? Coterminal. What do you think? What's that? Yeah, with. Okay, same, right? So basically, when we're talking about coterminal angles, we're talking about two angles that have the same terminal side. So there is our basic definition here for us. So coterminal angles are two angles that have the same terminal side. So what do I mean by that? So let me give you an example of what I mean by that. So let's say I had draw an angle in standard position. And for this example, I'm going to choose theta to be an angle of 3 pi over 4. All right, so 3 pi over 4. Where is 3 pi over 4? What quadrant does that terminal side end in? What quadrant would I be in? Quadrant 1, 2, 3, or 4? I'd be in quadrant 2, right? 1 pi over 4, 2 pi over 3, 3 pi over 4. So I'd have something that looks like this. So here, right here, there is my angle theta. So theta is equal to 3 pi over 4, okay? There's another way I could get there, though. Does anybody see it? How else could I end up in that same position in the second quadrant? What could I do? Think of negative. I could go the other way, right? I could take this route over here. I could call that beta. And what angle would that be if I went that direction? Well, let's see here. Negative 1 pi over 4, negative 2, negative 3 over 4. Oh, so beta is equal to negative 5 pi over 4 if I count backwards, right? Negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4. Boom, there I am, negative 5 pi over 4. So what we say then is that alpha and beta, these two angles are known as coterminal. They are coterminal angles because they share the same terminal side. Does that make sense? Yeah? What do you guys think? Is that pretty good? Okay. All right. Let me give you another one here. Let me give it to you in degrees. Okay. So what if I gave you an angle of 60 degrees here? Theta is equal to 60 degrees. Okay. So could you find another angle that's coterminal with 60 degrees? Give me one. What do you think? Say again? 120. Well, I don't know. 100 isn't 120 over here? Is that the same terminal side? Negative. What are you saying? Okay, I hear a negative 300 out there. Okay. Negative 200? Okay, I have negative 300. Okay, Jonathan, how'd you get negative 300? What'd you do, dude?
Because I subtracted 360, or I subtracted 60 from 300.
Yeah, so he went that way, right? Call that beta, and that'd be negative 300 degrees. Okay, good. Is there another one you guys can think of? Maybe a positive one? Jonathan, say again.
420.
He says 420. How'd you get 420 out of this? Yeah, so if I use a different color, like green here, check it out. If I go all the way around, right, to that one, then I've gone 360 plus another 60, right? So most people, when I ask them to do this problem, here's what they do. They take 60 degrees and they add on another full rotation, right, to get an answer of 420 degrees. Can you guys think of another positive one that's bigger than that? That's a great question. Oh my gosh, so now it's on. Yes, you can just keep going, can't you? So could I just go 360 twice and get 780? Could I just do that, right? And then now, how did I get 300? Isn't it true that 60 minus the 360 degrees, that gave us my negative 300, right? So all of these here, these are all coterminal.
But, okay, like, if
you are onto something here, right? So in general, check this out. In general, how many coterminal angles am I able to find? An infinite amount, right? Think about. So what is this pattern? We're starting with our angle, which was theta, and we have added or we have subtracted, well, 360 degrees because that is a rotation, right? But then there's multiples of how many times we want to spin around, so we just add on some constant k, where k is an integer, and that's how we write that. So this is how we can find any coterminal angle. We can then take our angle, add or subtract any multiple of 360 degrees because that is a revolution from wherever we start. Does that make sense? Yeah? So k, and then that funny e, z, means k is an integer. It's an element of the integer. So meaning like I'm going around, starting at 60 degrees and then going around one time. K would be 1. Starting at 60 degrees and going around 2 times, k would be 2, and so on and so forth. There'd be an integer, right? Okay. Well, this trick also works for radians as well. So I'm going to give you a radian measure of pi over 6. Theta is equal to pi over 6. Can you please find for me 2 coterminal angles to pi over 6? Yes, I can. All right. Anybody want to tell me how you thought about this? Anybody know out there? Tell me how you thought about it. Don't be shy. Don't be shy. Yes, Sarah, what'd you do?
I did Maddie's little trick.
Okay, what was it?
For 6 you do like 3 in
Okay.
each quadrant.
Mhm.
So I did that until I got to the line again, and it was 13.
Okay. So basically what we're doing is we're adding, right? We're adding a full revolution to our angle of pi over 6. And it's the same thing you're doing. You're just counting all the way around, right? So we're going to do that. I'm going to add on one full revolution in radians is 2 pi. All right, but to add a common denominator here, I would have to go pi over 6 plus 12 pi over 6 because that's the same thing as 2 pi, which of course gives me that 13 pi over 6, which is an angle that is coterminal to pi over 6. Okay, what's the other one? What's the other way we could do it? There should be a negative one that a lot of you got. Sanam, what'd you get? A negative 11 over 6? 11 pi over 6?
11 pi.
Okay. So we would just subtract 2 pi from this case. So it would be pi over 6 minus 12 pi over 6, which gives us the negative 11 pi over 6. And if you think about it in that direction, right, going this way, I've gone negative 11 pi over 6. That's terrible 11, but you get it. Okay. So in general then for radians, it would be your angle plus or minus 2 pi k, where k is some integer. So it's the same exact thing, except one uses 2 pi because it's radians, and the other uses 360 degrees because it is a degree. Does that make sense so far? Feeling pretty good about that? Here's one approach we could do. We could take our angle. We could take our angle of 400 degrees, and we could add on 360 degrees, and that would give us 760 degrees. So that angle is coterminal to 400, right? There's another one. What's another easy positive one that you could do? Well, okay, well, look, if I go around 360 and then a little bit more, and that's my 400, right? What's the little bit more part? 40 degrees, right? So 40 degrees is also coterminal with 400. These all end up in the same spot. Now, for a negative one, right, if I took 400 and I subtracted off 360 degrees, what would that give me? That would give me the positive 40, right? So what if I subtracted off another 360 degrees? What would that give me? There you go. So negative 320. So I could go the other way with it, right? So I could go this way. That's negative 320 degrees. So all of these are coterminal angles to 400, right? Now the book or the directions, they might say, generate a coterminal angle that's between 0 and 360 degrees. So you have to figure out which one is between 0 and 360. So in this case, we would use the 41. Or they might give you a certain parameter that say, okay, find coterminal angles between 0 and 420 degrees, or whatever it is. They might give you certain parameters. You just pick the one that falls inside because there are an infinite amount of these that we could do. Okay, for 17 pi over 6, I get 17 pi divided by 6. I added on a full revolution of 2 pi. And that gave me 17 pi over 6 plus I did 12 pi over 6 for 29 pi over 6. Did anybody get this one? 29 pi over 6? Did anybody get 5 pi over 6? Yes. Okay, so 5 pi over 6 also works. And then did you also get negative 7 pi over 6? So there's your positive and there's your negative ones for that. Remember from yesterday? We talked about these radians, or not yesterday, what it was, Tuesday. We talked about this picture that we had here. We had a circle with a certain radius. And we talked about there's this distance on the outside, which we call the length of S. And there was this angle of radians in between the middle there. What was the relationship between these three variables, between S, theta, and R? Do you remember what it was? Okay. Yeah. This angle equals S over R radians, right? So if I just want to solve for S, I would get S is equal to R times theta. This right here, this formula is called the arc length formula.
Wait, so is the R radian or radius?
The R is radius, the radius of the circle. Theta is measured in radians. So that's the warning for this thing. This thing comes with a warning. Okay? This right here, this distance is the arc length. Okay? Warning, theta must be in radians. Okay, this formula only works if your theta is in radians. Only works if your theta is in radians. So let me give you an example of what I'm talking about here.
Can't you just convert the degree to radian?
That's exactly what we're going to have to do. Let's say I've got a wheel and I have a radius of 10 inches, okay? And I put like there's a little dot on the end of that wheel, like a little sticker dot. And I rotate my wheel through an angle of 120 degrees. So my dot ends up over here. Okay? So how far has that dot traveled around the edge of that circle? What's the distance that dot has traveled? Okay? If you need to go, you can go, Jonathan. So check this out. I know that the distance, S, is equal to R times theta. So this distance, this is the arc length S, you got it, is equal to my radius, which is 10, times my theta, which is 120 degrees. But theta has to be in what? Measured in what? Radians. So I need to convert from degrees to radians. Good thing we know how to do that. S is equal to 10 times 120 times pi over 180. So that's my conversion factor from taking 120 into radians. So S is equal to 10 times 2 pi over 3.
Is it possible to convert after you like multiply 10 times 120?
Yeah, if it's all being multiplied together, yeah, that'll work out. So you should get 20 pi over 3, which was approximately 20.94 inches. So now we have a way, using radians, we have a way to measure distance on an arc. It's pretty cool, right? This is used when figuring out revolutions per minute of bicycle wheels, of different sized tires, of gears, all kinds of things.